Welcome to the Distant Curve Severe Weather Analysis for Brisbane. It's Friday, December 26, 2025, and we are looking at the atmospheric setup over southeastern Queensland. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. I'm your host, and today we are diving into what the atmosphere is telling us about the potential for severe thunderstorms this afternoon. Let's start by understanding what's happening in the air above Brisbane right now. Looking at the morning sounding taken at 10 a.m. local time, we can see a fairly stable atmosphere. The temperature profile shows a shallow mixed layer near the surface with a moderate lapse rate aloft. We are seeing relatively modest moisture content, with dew points indicating atmospheric moisture is present but not overwhelming. The wind profile is light in the lower levels, with some speed increasing with altitude. At this point in the morning, the atmosphere is capped, holding back the energy that will build as the day progresses and the sun heats the surface. This is typical for a summer morning in Brisbane, where the cap needs to be broken before afternoon convection can develop. Now let's look at what happens as we move into the afternoon. With solar heating, the surface warms and parcels of air begin to rise more vigorously. The enhanced analysis shows us comparing different parcel types to understand the maximum potential. As the afternoon unfolds, we are seeing the parcel path shift significantly. The red and pink shaded areas show the CAPE, the energy available for convection. This represents the fuel that storms would tap into. The transformation from morning to afternoon is substantial, with warm surface temperatures expected to break through the morning cap. The shear profile remains moderate, which will influence how organized any storms become. The environment is shifting from stable to unstable as the day heats up. Examining the wind profile and hodograph for today, we see a moderately deep wind shear environment. The 0 to 6 kilometer bulk shear is moderate, with backing winds in the lower levels and stronger winds aloft. The hodograph shows some curvature that would support organized storm motion if convection develops. For emergency services planning, this wind profile would support some level of organization in any storms that do develop. The right mover vector points in a direction that would carry supercells toward the northeast if they form. However, we need to remember that organization requires the energy component. Shear without CAPE is like a top without spinning force. The wind profile itself is favorable for severe weather, but it's only half the equation. The destructive wind potential depends on whether storms actually organize, which brings us back to the energy question. Looking at the Brunt-Väisälä frequency profile and overall stability structure, we see something important for understanding the downdraft environment. The stability profile shows areas of weakness in the mid-levels where downdrafts could accelerate if storms develop. The low-level stability is relatively weak, which means if we get strong downdrafts from deep convection, they would accelerate rapidly as they descend toward the surface. The dry subcloud layer that often develops in the afternoon would enhance microburst potential. However, again, this requires storms to actually develop and reach the mid-levels. The DCAPE values indicate the atmosphere has capacity for strong downdrafts once convection is established. For emergency response teams, if storms do materialize, the stability profile suggests microbursts could be a significant threat alongside hail and wind, with localized severe wind damage possible in affected areas. Looking at tomorrow morning's conditions from our machine learning forecast, we are seeing a very different scenario. CAPE values drop to just 0 joules per kilogram, with surface-based CAPE at 3 joules per kilogram. The shear is actually quite strong at 62.9 meters per second in the 0 to 6 kilometer layer. The lifting condensation level is at 904 meters above ground level. The storm indices, STP of 0.02 and SCP of 0.03, indicate subconvective conditions where there simply isn't enough instability to drive significant thunderstorm development. Even with the strong wind shear present, the lack of energy means organized severe weather is very unlikely tomorrow morning. Moving into tomorrow afternoon, the forecast evolution shows CAPE remains at 0 joules per kilogram with surface-based CAPE also at 0. The shear increases slightly to 68.9 meters per second. The lifting condensation level is at 905 meters. STP is 0.03 and SCP is 0.08. The ship index is 0.03, and the lapse rate from 700 to 500 hectopascals is 4.9 degrees per kilometer. The storm mode remains subconvective with insufficient CAPE for development. Tornado threat stays low, while hail and wind threats are conditional. If somehow storms did manage to initiate, there could be hail and strong winds, but without the instability to drive development, this scenario remains unlikely. Tracking the evolution of key parameters through tomorrow's forecast period, we see a critical story. The CAPE remains essentially 0 throughout the forecast window, indicating the energy constraint persists. The shear values are quite strong and remain consistently high, but shear alone cannot drive thunderstorm development without instability. Helicity and other rotation indices don't matter when there's no convective engine to spin. The timing signal is clear. Tomorrow is a day when the atmosphere lacks the fuel needed for severe weather development, regardless of the favorable wind shear. This represents a classic scenario where one key ingredient is missing, and that's enough to prevent significant severe weather. As we wrap up this analysis for Friday, December 26th, remember that atmospheric potential and actual outcomes are two different things. Today's sounding shows an environment that will warm considerably this afternoon, with moderate wind shear and a cap that needs breaking. Tomorrow looks much less favorable with low instability throughout the forecast window. Always consult the Bureau of Meteorology for official forecasts and warnings, and stay weather aware if you're in areas prone to severe thunderstorms. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia. Thanks for watching, and stay safe out there.